In this lesson, we're going to look at section 3.8, factoring special polynomials. In this lesson, you will learn how to investigate some special factoring patterns that are not similar to the ones that we've already covered in the form of ax squared plus bx plus c. Sometimes we are given questions that go away from the regular characteristics of that form, and we need to look for some special patterns. Our first special polynomial is a perfect square trinomial. A perfect square trinomial is a trinomial of the form a squared plus 2ab plus b squared. And it can be factored then as two binomials of the same binomial, so therefore we write it as a plus b all squared. And when you hear perfect square, you should remember the perfect squares 1 squared, 2 squared, 3 squared, 4 squared, and so on. So we have 1, 4, 9, 16, 25, and the list will continue. So this is the pattern that we're looking for in this perfect square trinomial. Does it start and end with a perfect square? So if you look at the way it's laid out, the a squared term and the b squared term must be two perfect squares in order for it to be a perfect square trinomial. And if this is the case, we have some rules. If you look at the bottom here, the square of the first term in the binomial, so it'll be a squared, twice the product of the first and the second terms in the binomial, that's your 2ab, and the square of the second term in the binomial. So you could end up having a perfect square at the beginning, but not at the b squared term, and therefore that would not be a perfect square. So when you're looking for your patterns to see if you can recognize this type of trinomial, you're looking for a perfect square at the beginning and at the end. Similar to this example here. 25x squared, subtract 20x plus 4. Okay, so let's look at our a and our b term here. 25, yes, that is a perfect square. How about 4? Yes, that is also a perfect square. So once we recognize that, we can look at rewriting it as a squared. So 5x squared, that does give us 25x squared. 2 squared does give us our 4. So once we do that, we're just going to take your a and your b term and you're going to put those in the bracket. So you're going to have two binomials of the same terms in each. So you'll have 5x and 2. And 5x and 2. So now we're not sure, is it both subtract? Are they both addition? Is one subtract or is one addition? Well, what we have to look at is that middle term, that twice ab, that 2 times ab. If that is a negative, then both your binomials are going to be negative. If it is positive, therefore both will be positive. Our next special type of trinomial is going to be a little different. It's going to involve perfect squares, but it's going to have a new name. It's going to be different. And that's going to be the difference of two squares. So unlike the previous example where both of them are positive or both of your factors are negative, in this case we're going to have one that is positive and one that is negative. So be careful you don't get those confused. If you look back at the other example, we have 3 terms in that trinomial, but this time we're only going to have 2 terms, and they're going to be in between a subtract sign, and that's why it's called a difference of two squares, because it is going to be a difference of two perfect squares. So when factoring an a squared subtract b squared expression, we're going to have a binomial here. It's not going to be a trinomial, it's going to be a binomial. The first and the last terms are perfect squares, similar again to the previous question. And the operation between the terms is subtraction. The factors of the binomial are the square roots of the first and last terms, where the binomials are conjugates of each other. So all you have to do in this example is take the square root of your a term and the square root of your b term, and that is what gives you your factors. And the way they say conjugates, that means there's the opposite operation. So one factor is going to be a positive and one factor will be a negative. So it's going to be addition and a subtraction. If we look at our example here, we have 36x squared subtract 9. we notice we do have a difference of two perfect squares. If you take the square root of 36, you're left with 6. If you take the square root of 9, you're left with 3. So we can rewrite it now as 6x squared subtract 3 squared, which is the same process we did in the other question, which was a perfect square trinomial. And we will write down our two terms. We have 6x and 3 in our first binomial, and we do the same in the second. But in order for our middle term to be canceled out, you have to have our conjugate of operations. One has to be a subtraction, and the other has to be addition. Now, it doesn't matter if the first one is a subtract or an addition. They can be both switched around as long as the signs are opposite. And in summary here, when factoring polynomials, check to see if it fits one of these special polynomial types. Look for a pattern, whether it be a perfect square trinomial or a difference of two squares. However, remember that x squared plus 16 is not a difference of squares, even though that 1 and 16 are perfect squares, but it is not a difference. It is only an addition. It is simply a binomial that can be written as x squared plus 0x plus 16. You will need to find two integers with a product of 16 and a sum of 0. So the only time we can have a difference of two squares is when those two perfect squares are between a subtraction symbol.